read something about educational engineering education. The floor is yours.
Thank you. Well, thank you for inviting me, Fan. There's a bit of a joke behind that, because when I saw the programme, I thought, God, the list of speakers, what a load of old farts. I mean, basically, everybody was so old. And so I wrote to Fan and I said, where are the young people? Where are the young people? And he wrote back and said, you come and talk. So I think I've just increased the average age even further. There are two of you, I think at least two of you older than me, but not many. So I've raised the average age, I'm sorry for that. But this is a slight break from the topics we've had so far. And I've been quite pleased with myself, because if I'm honest, I haven't done any metallurgy for between 20 and 25 years. But I could still understand nearly all the words that have been used in the last 12 hours. Not all of them, but most of them. So I was quite gratified with my own education. Something must have been right about it. So I'm going to take Martin Flixman's words, and I want to look back in order to think forward, because we have to start from where we are. We can't start from somewhere else. So I'll do my best not to fumble the slides. The first thing is I'm very, very interested in literature, much more interested in literature than I am in metallurgy. Oscar Wilde is one of my heroes, and I'm misquoting him here, but he might have said, engineering is too important to be taken seriously. And if you can't read the next line, I suggest you move forward. It says, if you sit at the back, you'll miss some of the jokes.
Right? You might use the microphone. Yeah. It's hard to hear you.
Oh, sorry. Yeah, I knew I was going to wander. Yeah, sorry. Thank you, Brian. Better? Yeah. Okay. Yeah, so if you sit at the back, you'll miss some of the jokes. This is important because this is the after-lunch session. Right, so I do recognise what happens after lunch, so the jokes are there to try and keep you awake. Okay, so I still can't work out where this points to. Normally you point it at the computer.
Above the arrows.
No, I'm pressing the right arrow. Right. So those of you from the UK system and as old as me will remember the term quinquennium, because universities used to plan in quinquennia, 5 years, and we used to know what our funding was going to be for the next 5 years. So the word quinquennium comes from that, but 5 years is too short a span in my life, all right? Because after 80 years there have been far too many quinquennia to go back and reflect on. So because I went to a posh public school and I've got Latin in my background, I've coined probably Pig Latin Viginti quinquennia, meaning 25 years, all right? So this is the looking backwards in 25 years. I still can't make this do the right thing. Where's it? Techies. Yeah, well, that doesn't work. Where am I supposed to be pointing it at? You. That's what I thought. But it's not working. Yeah, no, I'm pressing the right arrow. Yeah. But it's a light's coming on, but it's not changing. That one?
This one.
Yeah. Oh, that's what I'm pressing.
And it doesn't advance? No?
Well, there's a lot of advances. It's pretty important. Okay, so I look back. This is the looking back bit over my own education, broken into 4 Viginti quinquennia. All right, and in the first one, I'll call that youth for shorthand. All right, what did I gain? Click. What I gained in my first 25 years was what I would call hubris. In other words, cockiness. My public school was polite enough to call it self-confidence, which is a positive trait, but in fact it was cockiness, and not much else. So at the end of my first 25 years, Pig Latin, thank you. At the end of my 25 years, first 25 years, I would say I knew absolutely nothing. Right? And I could do absolutely nothing. And I think these are very important reflections on the future education. I regret to say I knew nothing, I could do nothing, but I had 2 bits of paper that said I was quite clever. Right? So that's all I had, 2 bits of paper that said I was quite clever, and nothing more. I lost something, and that probably took as much effort as getting a first-class degree in metallurgy, and was just as challenging. Thank you. Let's try this
A
one.
bit of pig Latin there.
Well, no mention of pigs here. Right, let's see if it works now. Thank you. So in the second 25 years, I thought of myself as a scientist. Right? And in that period, I did lots of the sorts of things you've been watching today of the 70s and 80s. And I did lots of experiments, and I made lots of theories, and I published lots of papers. And so the gain from that, I got a chair. Right? That's obviously what every young academic aims for. And I think I probably picked up some knowledge. So much of what I understood of the last talks came from that period, because I picked up quite a lot of knowledge, because I had to as a researcher and I had to as a teacher. There's nothing better than teaching for getting you to understand something. So what I lost in that period, I've never had this blight before.
You're pressing the pointer.
Okay, so what I lost was my hair. Right, so in that time, so that's no, I'm pressing the arrows. Don't believe me, but okay. So then there was the road to Damascus happened, and the next 25 years I really considered myself an engineer, and this is an important distinction I want to make later. And in that time, what I actually got was some attitudes, and my attitude changed to 2 things. It changed on the difference between science and engineering. So I learnt to think like an engineer. And I also learnt that teaching and learning was probably more important than the research I've been doing for the previous 25 years. And hence why I'm standing here speaking today, because my perception that was very important to the generations who come after us old farts. The education is hugely important. So I learnt that, and I lost my Achilles tendons, and so I can't run anymore, so I have to cycle. So that coincided with that change in exercise regime. And now in the 4th virginity quinquennium, which I'm now well into, and I insist I'm pressing the right button. This is just bizarre. So this is my dotage, right, the 4th virginity quinquennium, and in that time I'm about to gain. Don't I wish? Yeah, that's a good point. So in this period, I'm gaining a great grandchild in about 2 weeks' time. So that for me is a new move. And yes, thank you, Brian. I was looking around for, and I've lost, I'm afraid, a considerable amount of memory, and of course too many friends, as happens to anyone at our age. So that's a bit of looking back, and it's important because in being self-critical, I pick up changes in myself, which I now wish our education system could induce earlier. It took me too long to reach some of these conclusions. So. No, it doesn't work. Oh, here we go. All right, no, I want to go back. So let's start with something pretty basic. And this is UK data, but all of us from the UK will appreciate that there ain't many students in metallurgy, order of magnitude 0, and there ain't many in material science, order of magnitude 500, and dropping. All right, so there's not a lot of encouragement there for this community in the UK as we go forward. And there are no UK programs currently focused on metallurgy. I think the fan was talking to me last night about aspirations, which are fine. So that has been a perceived problem for the whole of my working life. That and the lack of women have been problems unsolved for the whole of my working life. So, but they become more important because when I started my working life, they didn't care. The fact we educated 30 metallurgists at a loss was fine. Now, if we educated 100 metallurgists at a loss, that wouldn't be fine. So that's the change in the environment, and we have to take account. We can't ignore these things. There is some hope in the general engineering population. These are figures for engineering students, again in the UK, I'm afraid. But there has been a 28% rise in engineering undergraduates over that 8-year period. That's from 2012 to 2020. Contrasted against only 17% in all subjects. So engineering's been doing quite well, actually. But 25% of those in the UK come from overseas, which is, again, it's a financial issue. It's a wonderful cultural comment, but it's not a wonderful financial comment because they've been brought in, I fear, and Vice Chancellors here will contradict me, of course, largely because they bring more money with them. And so they're an essential feature of the viability of the system, I fear. These lower two lines are for postgraduate taught people doing MSCs typically, of whom 50% are overseas. And down here, not even shown because the line would be not demerged from the baseline, are the materials cohort, which is very small. Up here, that's 90,000, and we're down below 1,000. I put a bracket there because you get a different number depending on where you look. So that's where we are, a little bit of hope. And I think the gloomy undergraduate picture, my comment is get over it. It ain't going to change. Get over it. There are lots of engineering and science disciplines who have chartered bodies who think of themselves as a body of professionals who don't have undergraduate courses. Tough shit, you have to learn to cope. And there's some more, including important things. And I when the programme was originally put out, Mark Miodovnik was either going to be just before me or just after me, I forget which is why I put in liquid state physics, because he's written a book on liquids. And there is no course in the UK, no programme, no course even on liquid state physics. And I would have thought this community and others would appreciate the behaviour of liquids is quite important. So we have to get over it. Now, an oxymoron. Our response in the 70s was to invent material science and engineering as a way of merging things and being more general and hopefully getting more students in. It saved us for a little while, but I think that's essentially an oxymoron. And I didn't perceive that at the time. I thought it would be lovely. We could combine the skills of a scientist and the skills of an engineer all in one undergraduate course. The undergraduate would come out the wonderful paragon of a graduate. Super. I don't think it happens, and I think it's very difficult. And the reason is this. If we want engineers, then I think attitude is more important than knowledge. Education is fundamentally about employment, and I would abolish the PhD in engineering. It's an utter waste of time. I chose my words very carefully there. I didn't say abolish research. I said abolish the PhD. And I could be tackled on that, and I have arguments about that. And the attitude of an engineer, which it took me 50 years to learn, is how can I do this desirable thing better? And the key word is not better, it's desirable. So how can I do this thing which is societally desirable better? And that's the key attitude that it's worth spending 3 years of time to inculcate into an engineering student, rather than on top of some facts and some stuff which has to come along. On the other hand, if you were a scientist, then almost the inverse is true. Knowledge is very important, the attitude is different, and the education is essentially about research, which is what you guys have been talking about for the last day and a half. All right? I'm still not sure whether the PhD is necessary, actually, but that's maybe an argument for another occasion. And the essential attitude of a scientist, to my mind, is how does this work? That's what Brian was talking about earlier with great enthusiasm. The curiosity. How does this work? We need to get in, experiment, discover. That's the attitude of a scientist, I think. So I don't think material science and engineering solved anything. Here we go. This is my favourite statement about engineering, and because, again, you can't read that from the back, I'm going to read it out. Engineering is the art of modelling materials we do not wholly understand, you'll have to agree, into shapes we cannot precisely analyse, so as to withstand forces we cannot properly assess, because we can't predict all eventualities, in such a way that the public has no reason to suspect the extent of our ignorance. That's hugely important. I mean, you know the joke about the most nervous guy on the plane biting his or her nails is the aerospace engineer, because they know that every component has probably been bought down to a price rather than up to a specification. All right? So I just put that in as a bit of a lighter side. Now, if we were to want a materials engineering program, I've separated materials science from materials engineering. If we were to want a materials engineering program, then essential topics might include: what are the materials going to be used for? Why? Where are they going to come from? What happens at the end of life? And we've heard some considerable discussion about that today. What are the energy and carbon implications of producing them and disposing of them? We've heard a lot about that. We'd want to know a bit about additive versus subtractive manufacturing, which we haven't heard a lot about, though someone did mention additive just in the last talks. And then we need to know a bit about modelling, data, statistics, digital twins, all things which have come up fairly recently, and anisotropy, which we have heard about. Now, I put those up. None of those featured in my metallurgy programme. So I got a first class in metallurgy in 1964, and none of those topics, some of them didn't exist, none of them was mentioned. And so, I think that's a lesson to us. If, on the other hand, you want a materials science program, then you've obviously got to delve into thermodynamics and kinetics. You need to know about the crystalline state, but also other micro and nano structures. You need certainly to know about surfaces and interfaces, because they are controlling. We had the debate earlier about what I called subgrains, and who was it? It was Harry calling them not subgrains. You called them something else. Mosaic structures or crystal misorientations, all the same thing. We need to know about that, and then we need to know other bits of physics and chemistry to your taste. I don't have a strong view on what other bits of physics and chemistry you put in, but you'll put some in, I'm sure. So that's a very different program. And now, if we were to want a program about a specific class of materials, and that's what you're asking, you're interested in metals. They're not, and we've heard vast figures about the importance of metals and the tonnages and how much of the world's energy they're using to make them and so on. But there's a lot of other materials we should be thinking about. Carbon, concrete, stone and brick, metals, polymers, wood, ceramics, semiconductors, composites, layered materials. I've worked on half of those in my life at various times, and some of them are newish. But one of the things we often miss is that some of these are crying out for development, even more than metals are. I think concrete, because it is so energy and carbon expensive, that's worthy of the world's attention to a greater degree than we're giving it at the moment. I would say the same about polymers, because we've learnt to make them last well, which is probably the last thing we want of them, and we've got a long way to go, I think, with polymers. And the other one, which I've become more sensitised to, because one of my hobbies now is wood turning, is wood, which we are wood. We're pre-Bessemer with wood, I think. It's got a long way to go. There's a huge scope for controlled wood products, which have the advantage of soaking up carbon as well, or parking carbon, shall we say. So those are some of the things, and you'll see why I've been listing them. Now on to the environment in which we want to do this education. And I think the environment has changed quite radically since we old farts were at university. And here are some of the ways it's changed. The expectation now is that learning should be more active. All right? The hour-long lecture is not one of the best ways to transmit attitudes and even knowledge. It's regarded as expensive. It is expensive. In the UK, I know in other countries that they've attacked this differently, but in the UK, it's quite expensive, viewed from the perspective of the student who's accumulating the debt. It may not be considered expensive in absolute terms. It's increasingly local, because students, partly driven by expense, are more and more living at home. And in fact, come on. The local bit, 37% of students in the UK now live at home. So that begs the question, if they're to have involvement of local industry or experience locally, is that spread uniformly around the country? Can your local university actually access the experiences you want its students to have? Backing up a bit, the expense, can your program accommodate part-time work? Because increasingly the students will need part-time work. And the first one, if it's to be active, what are they going to put their hands onto? Now that's easier for engineering students because they build stuff, and they build stuff in teams, and you can mock that up and they can build things. It's harder, I think, for a metallurgist to build something. It's harder for them to do a real process. They can do experiments, yes, but the actual real, pseudo-real stuff is harder to imagine, and I'd be interested in people's ideas. The education's optional. We're more and more seeing in my pretty Cheshire villages that I live in, more and more kids are not bothering to go to university because they've already got the social networks they want. They're perfectly happy. The reason I went to university, to get away from my parents and to lose my virginity, they've already done that by 18. So, why do I go to university? The other thing I put here, increasingly education is team-based. And we have to ask the question, what for a metallurgist is a team? Often he or she is one person in a team of other engineers. So we need somehow to create that rather than put 4 metallurgists together. And the other thing is mixed A-levels. Increasingly young people are told, and I don't have a problem with it, study the A-levels that you think you enjoy most. Don't study them because they lead to a degree in materials or metallurgy. Study them because you're fired up by them. And that's leading us to have a lot of student applicants with quite a wide spread of A-levels. So all those things are there in the background. What prior study topics do you want? I won't even attempt to answer that question. More things about the context. ChatGPT, lot of debate in the press in the last 6 months. It's here, use it. Universities trying to do a Canute and say, no, stop, you're not going to use this. Forget it. You've lost the battle already. Students will use this sort of tool. You have to devise an assessment system which tests them on what they understand of what ChatGPT has brought into their inbox, right? Which is a different approach to assessment, but you can't stop it. Can't be done. Likewise, big data, because so much data is big now and we've got techniques for handling it, I think the approach to the Fermi problem becomes more important. Right? The classic Fermi problem, how many piano tuners are there in Chicago, is the classic one. You can get to within a factor 2 of how many piano tuners there are in Chicago without knowing anything, except that Chicago is a fairly big city. That's all you need to know. Right? And that approach to big data we need as a sense check. And students need to be doing that routinely. Multiple careers. My children, both age 50 or 50 and 52 now, are on their 3rd careers each. This is going to be quite commonplace. And so therefore, lifelong learning, taking people back in to top them up, give them something fresh, it's got to be a natural part of the education program. I used ChatGPT. When I got to this point, I typed into ChatGPT, what's the future of metallurgical education? And you won't read this, but I was quite encouraged. It gave me quite a lot of the buzzwords I'd already used in a text form: changing needs of industry, additive manufacturing, nanotechnology, flexible, adaptable, machine learning algorithms for predicting the properties of new materials. That was all that came out of ChatGPT in a minute. Right? And then
what was your query?
I said, what is the future of metallurgical education? Right? Exactly the title of my talk. and so then I typed it in again, which you're allowed to do, and you get a different answer, of course. And this time it put it in bullet points, but it mentioned it mentioned a variety. Oh, no, that's the same one. This is the second time it gave 5 bullet points. Lifelong learning, which I've just closed with, right? Practical skills. It does mention welding and casting as particular practical skills, and I'm not particularly saying our undergraduates should be able to weld. I differ from ChatGPT. But interestingly, ChatGPT only seemed to know about the demand side, in other words, what employers would want, not the supply side, what would students want to study. And without that one, you don't get any students. All right? So both sides of that equation are important. So I think what the future might look like, this is the future bit now, in a virginity quinquennium or two, I think we might have a couple of BScs left in material science. I think we'll have more general engineering BEng courses, and I hope they'll only be 3 years long. I think we'll have master's programs in specific materials, and I gave you a vast list of materials, all of which would deserve an in-depth master's course. And I think we'll have short micro-credentials, is the jargon, courses in niche and rapidly changing topics. Our job is to get in bed with the people running the general engineering courses and make sure they contain a significant chunk of materials. That's our task, I think, to get in there among them. You might have niche courses on layered materials or battery materials or whatever is this week's flavour. All right? And the major aim of the general engineering course is to set the attitude I talked about before. So back to Oscar Wilde. He'd always been enthralled by methods of science, but the ordinary subject matter had seemed to him trivial and no import. Well, that was the picture of Dorian Gray. If you translate that into the NFT digital image of Dorian Gray in 2023, then he'd always been enthralled by the methods of engineering, but the ordinary subject matter had seemed trivial and of no import. And I'm actually of that view. I have a lot of engineering friends. What we share is attitude. What we don't share is things we know at all. I've got very good engineering friends with the same qualifications as me we share nothing except attitude. Right, the chairman is getting irritated. Freudian slip. But basically, I think first degree should be more general. We need to get more involved in that general curriculum. We get deep knowledge later. And I'm encouraged. I think we should play in this space. And one of the things it's difficult to do is what Mark and Brian were saying yesterday. It's very difficult to play in that space because we're so constrained by regulation and quality control and so on. So it's very difficult to play in the space I've just been describing. But I think we need to. We need to experiment. So I'm skipping that bit. If there was time, I spoke a few years ago at a British Science Festival. These were the topics of the sessions at the British Science Festival. Every one of them was engineering. There wasn't a science topic there. The Large Hadron Collider, it wasn't about hadrons, it was about the Large Hadron Collider, which is a massive piece of engineering. Life's about engineering. And there is an elephant in the room. So this is my favourite cartoon of all time. At the Climate Summit, what if it's all a big hoax and we create a better world for nothing? I think that's one of the wittiest cartoons I've seen. So thanks for listening. Now fight back.
Thanks for the wonderful and inspiring talk. I enjoyed it. Any questions? Yeah.
Oh, good. I've offended Harry. That's all right.
No. So you're not offending me. I get what you say, but I think the university system in Britain and generally is very versatile. So different universities have different foci, and a materials course in one university will never be the same as a materials course in another one. So I don't think we have a big issue.
But you can't deny, Harry, that we don't have a way of producing metallurgists at the moment. Do we?
We cannot actually create people for specific jobs in industry because industry will come and go. Yeah, so we can't any longer afford to educate people for specific industries.
In principle, I entirely agree with that. That's what I wish the system was like. I'm less optimistic about being able to do it, because I think we're driven by other shorter-term forces. Than I would want people to know a lot of basic stuff. The second law of thermodynamics has been hugely helpful to me over all my virginity quinquennia. I think, and I don't regret knowing it. But it's hard to persuade an 18-year-old of that, I think.
Yes, I don't actually agree with you, Peter. I'm sorry, and I'm not going to fight back too hard. But so let me tell you, let me give you very briefly a counter-argument. You took, I think, as assumed that what we're trying to do is create metallurgists for the metallurgy industry, and Harry's just said that's not what we're trying to do, and I agree with Harry on that point. Now, I'm an idealist, I think, and I'm certainly an optimist. In the first half of I'm going to take longer than 25 years. In the first half of my lifetime, that's roughly up until the 70s, probably more like the mid-80s, we were still in the post-war period where education was an idealistic enterprise to create educated citizens of the UK and make it a better place to live. Now, that was incredibly idealistic, probably naive and probably over-idealistic. Since the 80s, and Mrs. Thatcher has a lot to do with that in the UK, but it's not entirely her fault because the same thing has happened in many other parts of the world, education has become a process for people to get jobs. And I think that is fundamentally wrong. You actually wrote there, the objective of education is for people to get jobs. And I don't believe that. I believe it's to educate people. And I think ultimately that is more important. Now, I'm not saying getting jobs is not important, but it has become the only thing, and it's become certainly the dominating thing. And I think that's really bad, and I would like to see us get back to, not as idealistic as it was in the 50s and 60s, but a more idealistic perspective on education for people to develop their own abilities, their own skills, their own understanding of the world in much more generalised ways. And I would like to see metallurgy personally be part, not honed to particular industries, because as Harry says, the industries change, the industries wants very specific stuff, which I don't think is necessarily terribly valuable. You do learn that on the job, go on a training course. We want to teach people to understand the underlying science and the engineering principles, by the way. There are engineering principles too about how you approach those with those attitudes, how you change things. So all of that, I think, is what we should be educating. And we've stopped doing it almost exclusively. And the reason is students want to get jobs. We've told them that's your job. As a kid, you ought to be doing your education to get a job. So they're now asking for it. And we find we've got to bloody well deliver it. And it's really bad.
No, we don't differ hugely on that point. I mean,
you wrote up there, education is so they can get jobs.
You can't believe everything you read on the screen. Well, you should have learnt that. No, I think it's a basic discussion between education, which we value hugely, and what is saleable to the government and to young people. And that's a tension, because I agree with you. I would like to think that we were.
But we've given up. We've rolled over and let the government dictate that.
Well,
it's been a disaster.
I'll be briefer than Ryan. Well, I've seen a trend in the United States where deans and everybody talk about training students. And I keep telling them my job is to educate students, not to train them. You train a welder to do TIG welding, and then when TIG welding goes out of style and he has to do some other type of welding, you retrain him. You educate somebody and they can go from one job to another because they have the fundamental knowledge base. And that I've seen a trend in the United States, and I see it's probably true here, that we're talking about training rather than educating people. You train for a job, and then you have to retrain for another job. That's not our function, in my opinion.
Absolutely agree. But our government tells us that our graduates should be going into wealth-creating industry. That's what they say, and we had to push back.
Most of the things our governments say we shouldn't do.
Well,
Education is by
just
Brian.
Brian and John, just to add to that debate, I remember in the first week of my metallurgy course at Sheffield, a particular lecturer shot up, a bit like a joke slide of Peter's. What's the best example of a trained man? Sorry to be sexist there, a trained man. And the answer was a metallurgist. That was across the entire sort of career community. So, turning up the clock, we were training metallurgists back in the 60s and 70s. Maybe that was wrong in terms of the quality of education they were, but I seem to remember that industry, the career opportunities, welcomed those trained people with open arms. I think the problem is now, yes, younger people want a natural stepping stone, but it's very interesting now that the feedback from industry is, where have all the metallurgists gone? That's often quoted, and we're not getting the type of product from the output of universities that can come into our businesses from day one and start moving as they used to do. So there is a disconnect that's going on. Sorry if that's a part comment, but Peter, I'm looking for a response.
Oh, you're looking for a response? Oh, wow. I do think industry needs to take a bit of responsibility for that final thing. My model, my education model a la Cantor, would be a general degree which embedded a lot of basic stuff, followed by a specialism in which I imagine industry might have quite a big part to play. But it shouldn't expect to buy our BEng graduates industry ready. I don't think. I think that's an unrealistic expectation.
Okay. Thank you for this wonderful talk. You stimulated a nice discussion. Thank you.